In the Newton's laws experiment, students will measure the force on an object and its acceleration using this setup. So there's a digital force sensor here connected to our data logger, and there is a rotary sensor here also connected to the data logger. And so the rotation of this pulley can be measured over time and used to determine the linear acceleration of the string wrapped around the outside, and therefore the mass that is hanging off the end. So there is about 200 grams of mass hanging off the end of that string. Now, as I pull the force sensor back and forth, I'm accelerating that mass, and therefore the force that this will measure will change as I'm accelerating it up.
It's important that when you calibrate the force sensor that you hold it so that the hook is horizontal. In doing so, you avoid calibrating the weight of the hook itself as part of the measurement. As you'll see when I turn this vertical, the force that's read out increases, and when I turn it upside down, the force should decrease. That's actually due to the weight of the hook. So in this experiment where the hook will be horizontal during the actual experiment, we want to make sure that the instrument is calibrated so that it's reading a zero force at that orientation.
So in Logger Pro, your students will plot the data. They can convert angular acceleration into linear acceleration, and then plot the measured force versus acceleration. Their data should look something like this, although you may see something like this depending on whether a positive force produced what the computer called a positive acceleration versus a negative acceleration. It's certainly easy enough to change the sign of the acceleration to get a curve that looks like this. And then at that point, they can analyze their graph by doing a linear fit. And that linear fit will give them the parameters that they need to extract to determine the weight of the object and its mass. So the weight of the object will be determined by the intercept of the graph. The y-intercept represents the force when there was no acceleration, so that is the weight. And then the slope of this graph will be m, the mass of the object.
For measurements of Newton's third law, we will disconnect the rotation sensor from the apparatus here, and in its place, we will plug in an additional force sensor. Actually, we plug that into the top, the analog sensor ports, and this will allow us to record force from two different sensors simultaneously. And then the students will simply hook them together and have sort of a tug of war. Either one student can do it with